Hello everyone, FunshineX here, and this is a ComputerCraft tutorial on the ComputerCraft release 1.45. It is currently, as I'm filming this video, in beta, but it should be out within next week. This update is really cool. It adds 3 or 4 new features and fixes a couple bugs in the earlier versions, and let's get started really quick showing you those new features. The first one are the advanced computer and the advanced terminal. You can see there are these gold color blocks here. The advanced portion of them is that they are now color capable, and they also have the terminal has mouse support. So let's go check out how to build them. In this chest I've got some ingredients here. To build the advanced computer, take gold, just like you would with stone for a normal computer, and you've got the advanced computer. For the monitor, it's the exact same as a normal monitor, which is gold instead of stone. Perfect. Okay, so we can put those down on the ground like I have already done. And you can already see right away just here there are some color. It's really cool. Just the basic user interface has colors. So as we do different things, you can see that. If you go into my topics that I'll cover in this tutorial, you can see that various things are colored also in the edit window when you're editing your program. So things like if and else or do while function, and anything that's like a Lua reserved word will be colored yellow. Anything that's just surrounded in quotes will be colored red, and comments will also be colored red. That makes it really easy when you're writing your programs to kind of see if you've missed a then or a quotation or something like that. So I really like the new coloring in the edit. To actually set the text color when you're writing to your own terminal or monitor, you just call term.set text color, and you provided a color. And you can also do the same thing with the background color. So by doing this, you can get some really cool effects, and this works again on the terminal and on the monitor. The mouse support is only on the terminal because you can't really click on the monitor, but you've got a new event, and there's actually a small change in the latest release I need to change. It's now called mouse click, and the order is now button XY. So if you pull this event called mouse click, you will get the button will be either 1, 2, or 3, 1 being your left mouse button, 2 being your right mouse button, and 3 being the middle. For a Mac user, I am not sure. Don't ask me. I've never used a Mac in my life. Well, I guess that's not entirely true, but I don't know much about their mouses. X will be the X coordinate in terminal, so in this terminal is 1 to 51 based on where you click, and the Y coordinate is from 1 to the bottom, wherever you go there. And you can see even in the edit window I can now mouse click, which is awesome, and I'll put the cursor where I want it. There's another one. Let me write that real quick. It's the exact same thing, so I'm not going to write all that portion, but it's pulling the event mouse scroll. And this one doesn't have any X and Y. There's nothing there. But the button will be either a positive one for scrolling up, and negative one scrolling down. I'm going to have to verify that, and I can't remember which way it is. I'll show you that in 1 second, how that works. So that's how you're going to call to get to access the new features. So let me edit this guy. And I've got a color test. And if we go to color test, if it says it's going to put the standard color, blue text, green background, and it's also going to cycle the background through a yellow color. So let's look at color test. So printing the standard color, obviously the exact same way you do it before. I'm going to sleep a second, and then I'm going to go ahead and set the text color of my terminal to blue. And then you have the colors API to access all the colors, because normally colors are like 1, 2, 4, 8, 16, 32, and it goes up, so it's hard to manage just by the integer value. So use the colors API, and you can access all 16 colors. So that gives me the blue text. On the next one, I'm going to set the text color to black and the background color to green. And you notice when I did that, it didn't set the background of the entire terminal. It just set it behind the text that I'm printing. So that can give you just kind of like a highlight, a highlighter over text. Let them sleep a little longer. And this one, I'm going to go ahead and set the background color to yellow, and then clear the terminal. And when you clear the terminal, it basically term.clear fills the entire terminal with a space character. It's just kind of what it does in the background, so you get the entire thing to change color, and that's why the screen turned yellow there at the end. So that's really, really easy. And then at the very end of your programs now, you're going to want to start doing this. You always want to set your text color back to white, your background color back to black, clear the terminal, and set the cursor position back to 1, 1. If you don't, and you happen to set your background color to white, and your text is white by default, it's going to be really hard to know what you're typing. And you're now, well, at that point you can really just reboot the machine, because that should reset it back to its original. If you want to hack a computer, edit, set its background color to white and on startup, and no one will ever be able to type into it. Yeah, fun stuff. Okay, so let's go over here. Terminate this guy, give me nice red text, and let's look at the mouse test program. You're going to notice on this one, it's not really doing anything, it's just pulling events. And as I click, here's the left mouse button, and see I got the mouse click event. Button was 1, and it told me X was 24, Y is 10. So let's go click way up here in the top corner. 1, 1, down here, 51, 19. Okay, let's use the right mouse button right in the middle. Pretty good. And then I'll use my middle mouse button over here. Oops, I gotta scroll in there. 3, 1, 19. Okay, so that's the clicks. You can see it's the mouse click event, the button of the mouse 1, 2, or 3, and then the location on the screen. The next one is the scrolling. I'm going to go ahead and scroll down, and that gives me a positive 1. Scrolling up gives me a negative 1. And you can see I've just got there, so let's terminate out of this. And real easy to do. You can see I'm just doing pulling the 3 parameters from OS pull event, and I'm going to print out what the event was, what the button that was clicked, the X coordinate, the Y coordinate. So mouse scroll does give you coordinates. You're probably not going to use it, right? Because you just really want to know if there's users scrolling up or down. Okay, so now you've got all the new features. Let's show some of the cool things you would do with them. So I've got one called status display. Oops, let me show you what that does first. I've got a monitor here on the right, and I'm printing the status of these redstone signals. I don't have red power in here, so I'm using vanilla. But I'm printing the text in green. You can see it doesn't change all the text, it only changes the text as you print it. So if I turn the back one off, or the left one off, sorry. Let me actually run the program. That was just residual there. You can see it turns off, and I turn it on, it goes on. The back one does the same thing. And you could use this for a number of things, like if you're monitoring temperatures of your IC2 machines or engines, if you're monitoring if chests are empty or full, you can really easily now alert yourself with bright red text, hey, something's wrong, or green text, or the status okay, something like that. So you can do pretty much whatever you want. These nice vertical monitors just build up a stack and have all 16 colors from a bundled cable coming in here and report on them. So that's really cool. Look at the program real quick, because you guys always ask. This one, I didn't really optimize it. It's kind of just a test program. But I'm going to wrap the monitor on the right side. I'm going to get the input of the back redstone signal and the left redstone signal. Clear the monitor. Set the cursor position back to the top left. This is just a way to inline compare. So if this is true, then output will equal on. If backRS is false, then output will equal off. It's a really cool little shortcut. I do the same thing with the colors. If backRS is true, meaning the signal is on, then text colors equal to colors green. If it's false, it equals colors red. So remember, I only wanted to change the color of the true or false, on or off, right? So I'm going to set the text color to white to print this B, like the back, you know, and then set the text color to either green or red and print out on or off. I'm going to go to the next line and do this exact same thing. Compare the left red signal, print out L in white, print out on or off in green or red. That's really all there is. Sleeps a point second and then updates again. So that's some really cool applications we can do with these. Okay, what did I do on this one? Oh, okay. So let's do what does color monitor do? Oh, all that's doing is showing you that the monitor supports colors as well. So I can have purple text. So let's do color chooser. So this combines everything. It tells me I wrote this. It says left click to choose the monitor text and right click to choose the monitor background. And I've got myself a little color list over here. So if I click on orange, you'll see that, oops, that not work. Oh, come on. It was working before I started filming. Oh, I know what it is. I updated the pre-release. One second. So here's some of the code, and I just had event equals click. That was the old event name. Now it's just mouse click. So let's try that again. So let's click on orange. Okay, I still gotta fix. Oh, I forgot the order changed as well. So P2, P3, and P1. Just gonna fix these really quick, and then I'll show you what it's actually doing real quick. Okay, one more time. There we go. Orange text, yellow background, gray text, red background. So basically I can left click to do any different color of the hello world there. You can see it changing colors in the background. And the same thing, right click to set the background. So what I'm doing here is I'm using the mouse click events to find out which pixel was clicked on. You know, if I click over here, nothing happens. But if it's on this last row and it's one of these 16 rows, then it'll actually update and print out in color to my monitor. So really cool. Let's see how that program works. Oh, I think I know right here. Okay, so monitor's on the right side. I'm going to have running equal to true just for my endless loop. My default colors are white text on a black background, and text scale I don't need anymore. I was testing something. Okay, so while running is true, we're going to go ahead and clear the terminal, set our cursor position to the top left, and print out this help message to the user to know how to pick their colors. And then I'm going to do a loop from 0 to 15, so that's 16 times. And I'm going to set the cursor position 51, which would be the far right column of the terminal. And then I plus 1, so it's going to go from 1 to 16. Because remember, I is 0 to 15, so the columns will go 1 to 16. And the background color, I'm going to take the value of I'm going to bit shift it to the left. What this does is basically just takes 1 and shifts it on binary scale to the left, so you get 1, 2, 4, 8, 16, 32. So that gives us all of our colors without having to realize the values of each one. So that's really cool, this BL shift. You'll want to use a lot if you're working with colors and incrementing them. Term.set background color. So I'm going to go ahead and set the background color of the terminal itself. And write spaces. So, okay, so that's, you actually have to, to fill in that color on the right side, set the background color and write a space. That's the trick to just get it, just the background there, because it's highlighting your text. And then I'm going to go ahead and pull an event, and if it's a key event and it's the X key, then I'm going to go ahead and set running to false. That's kind of how I'm exiting my program. But if it's the mouse click event, and the P2, which is the x-coordinate, is 51, meaning it's the far right column, and the P3 is less than 16, so or less than or equal, so it's one of the 16 colors. Then I'm going to check if the mouse button that was clicked, which is the first parameter, is equal to 1. That means with the left mouse button. If it is, I'm going to go ahead and set the text color of my monitor. And I'm just using that same BL shift. Subtract 1 here because P3 is going from 1 to 16. I needed to go from 0 to 15. And if the the right mouse button was clicked, then I'll go ahead and set the background color the exact same way. And then I'll go ahead and set the text color of my monitor to whatever's chosen, the background color to whatever's chosen, and go ahead and clear the screen. Set the cursor position back to top left and print out hello world. And that's all there is. At the very end of my program, I do that cleanup, set my background color to black, and go back up to the top left and clear the terminal. So let's see that work one more time. So we've got our text here, our list of colors here, and then I can go ahead and pick some cool colors. Alright, got one more thing to show you over here. I gotta set it up, I'll be right back. Okay guys, I'm here. I've got a very giant advanced monitor, an advanced computer. I'm gonna go ahead and show you some of one of the cool programs I wrote on here. If you're familiar with a thing called Mandelbrot, it's a set of complex equations that determine I don't know a lot about it. It just makes a really cool picture based on complex math. And so I wrote one. Type in Mandel. Here we go. Watch the magic. Yeah, you guys have seen this, right? Very familiar looking thing. It's very low resolution, of course, because we've only got like 80 by 26 or something on our max resolution of our monitor. But it's pretty cool. If we edit the Mandelbrot, and I'm going to send it to the terminal instead of to the monitor. So now it's I could do the exact same thing here. What I did here is I wrote functions that, or I wrote handlers, so if you click anywhere on this, it'll zoom in or zoom out on the where you clicked on. So if we want to go look at the back thing of this thing, my scrolling is not perfect because it seemed like it zoomed in over in the middle, but let's keep trying to zoom in. It likes to zoom in on the void. But you can see if we had a little bit higher resolution, this would be pretty cool to zoom in and check out all the cool little patterns. If you get in here, though, there's little spirals and stuff at the end of the sky. If you go on the wiki, Mandelbrot, just search Mandelbrot in Wikispace or WikiLinks, whatever, and it'll show you all the math involved. But I thought it was a cool way to show the colors that the monitor can do. It is a very intensive algorithm, so it gets really slow as you start zooming in. But it is pretty cool. Okay, so let's see how this thing works. I have a clear monitor function that just sets the background color back to black and clears it. This two monitors controls whether it's the Mandelbrot is printed to the monitor or to the terminal. I set the width and height equal to the get size of the monitor, but if two monitors faults, then I get the size of the terminal instead. And then I have these variables. The origin is the middle of the screen, and the zoom factor is 1 at the start. And a way to log some debug messages just while I was testing it. It's pretty standard stuff. Okay, so this is where you start getting into this compound math. You have to be able to scale the screen coordinates to the Mandelbrot coordinates. Mandelbrot exists between negative 2.5 and positive 1 on the x-axis and negative 1, positive 1 on the y-axis. But our screen is 1 to 82 and 1 to 26, I think. 27 maybe. So how are we going to convert that? And that's just basically a shrink, a translation, and another translation. So don't worry about this complex math here. It's just basically taking screen coordinates, converting them to Mandelbrot coordinates. And I think here with my origin is where I'm getting screwed up on my zooming in, but I'm not going to worry about it. Get to color is one of the coolest things about Mandelbrot because you can color it all wacky and weird. There's this variable called iterations, and that's basically how many times the Mandelbrot was able to run for each coordinate until it exceeded a value. And you can see that math later. But if it gets to 1,000 before it gets out, then it knows that it's like a void in the Mandelbrot, so you always color that black, is usually traditional. But then to get the rest of the colors, I'm kind of using that bit left shift again, and I'm doing some other things where I'm taking the value is going to be from 0 to 1,000, and I'm going to go ahead and take the divide it by 2 so I get smaller range, round that off to the nearest integer, do the modulus operator by 15, so now I've got 0 to 15, which is what I need. Add 1 to get, and then bit shift it left so you get the cool colors. Writing out to my debug log just so I know a few things. And I've got this function called draw Mandelbrot. This is where your math is going to blow you away, so if you don't like math, turn away now. We iterate through every screen coordinate. So I'm first going to go on the height axis, so from 1 to the height of the terminal or the monitor, and then inside there do a second loop from 1 to the width. And I go and call that scale function, which scales our screen coordinates to the actual plot coordinates. Set x and y equals 0, have these iteration values, and then you do this while loop. X squared plus y squared is less than 2 squared. Basically the distance from the origin out to the plot line, whatever, to the pixel is less than 4. Kind of finding the distance there. And as long as the iterations is less than 1,000, then you keep doing this loop. You square the x, subtract the square of the y, and add in the scaled pixel coordinate y. So this is all in the Mandelbrot equation. You can go look it up. Increment the iterations. So if this iterations gets to 1,000 before it's greater than 4, then it'll be black. If it goes over 1,000 before, then we get this cool color based on what the iteration was when it went over. So I'm going to go set the background color based on the getColor function. If we're putting it to the monitor, I'm going to go ahead and set the background color of that pixel. Remember, we're working on a single pixel. And then set the cursor position and write a space. If it's to a terminal, the exact same thing, just print it to the terminal. Sleep point 1. You have to sleep in here because this takes like 3 or 4 seconds depending on how far zoomed in you're on, or even longer. And you have to yield every, I think it's 1 or 2 seconds in ComputerCraft, or it starts complaining at you. So sleep accomplishes a yield. So I sleep at the end of every row. At the beginning of my program, this is where it actually does the stuff. It clears the monitor, draws the basic Mandelbrot, and then goes infinite loop. Gets the mouse, just waiting for a mouse click. When someone does click with the mouse, if it's left, it zooms in. If it's right, it zooms out. And then I have this, make sure we don't get too far zoomed out. We can't zoom in a negative direction. And then based on where they clicked, I'm going to go ahead and set the new origins. I think I need divide by 2. That's probably where my error is there. But anyway, then I'll clear the monitor again and draw the new Mandelbrot based on the zoom functions. That's all there is. 97 lines to generate this cool thing. I want to know what you guys can do with color monitors and color terminals. Please show me. Just link to your creations on YouTube or a picture on Imgur. And I'm going to post this on the ComputerCraft forums with all the code for free. You go get that. It's going to be under the media section. My YouTube video will actually have a link to it. This has been FunshineX. I will see you guys later. Looking forward to ComputerCraft 145. Goodbye. Bye.